Earlier, he served as head and chairman of water resource and as a member of technical advisory committee at National Institute of Hydrology. He also worked as coordinator for AP State Cloud Seeding Project. He is also an expert committee member at several state and central government bodies, including UPSC, DST, CSIR, state and central groundwater department, and agencies. He was a founder of continuing and distance education at JNTU Hyderabad. He was an honorary research follower of Birmingham University, UK, and Rutgers University, USA. He has published over 170 papers in national and international journals and attended conferences apart from guiding several PhD and MTech students. He is a recipient of many awards and honors like
Ma'am?
Andhra. Yes?
Sorry, Shalini, ma'am.
Yeah.
Ma'am, I think there's little echo, ma'am. Could you
From
just
my
put... Yes, ma'am. Could you just check the speakers, ma'am, once? Just to check the earphones, ma'am.
Can you hear me now?
Yeah, now it's better, ma'am.
Should I continue or proceed?
I think you can continue, ma'am.
Okay. Published over 150 papers in national and international journals. Now, and is it still echoing?
Yes, ma'am. Ma'am, I think you just join in again. I'll take over from here, ma'am. Good afternoon, all. Sorry for the little disturbance. I hope I'm audible and my voice is not echoing. Charan, is my audio clear?
Yeah, your audio is clear.
Okay, sir. Thank you so much, sir. I'll just continue with that. Sir is an expert committee member at several state and central bodies, including UPSC, DST, CSIR, state and central groundwater departments, and GHMC. He has published over 170 papers in national and international journals and attended conferences apart from guiding several PhD and MTech students. He was an honorary research fellow at Birmingham University, UK, and visiting professor at Rutgers University, USA. Sir is recipient of many honors and awards. The Andhra Pradesh Scientist Award by Government of Andhra Pradesh, National Geoscience Award from Government of India, Meritorious Teachers Award by Telangana State Government, Sri Ram Srinivasan Award for Association of Exploration Geophysicist, Indian National Science Academy Teachers Award. Sir is currently working as a professor of water resources at JNTU Hyderabad and as a former Director Institute of Science and Technology. Today, Sir will be presenting on the topic Water Management in Sustainable Development and Planning. We request Dr. B. Venkateshwara Rao to address the session. Thank you so much, sir.
Okay, thank you, everybody, particularly for introducing me earlier, Shalini Madam and President Madam N.G. Lakshman.
Yes, sir. I'm Neha, sir. Neha Lakshman. Thank you so much, sir. Our pleasure, sir.
Yeah, and first of all, I would like to know from you people whether my voice is clearly reaching you or not.
Sir, it's absolutely clear, sir.
Okay, thank you. And of course, I am not playing my slides here. You are playing it. So as and when I said next, you can just change the slide. I hope
sir.
my cursor I can move from here and you are seeing it. No.
No, sir. I'm afraid not.
It's
sir.
okay. Doesn't matter. Doesn't matter. So friends, I think I'm starting now. Okay.
Thank you, sir. Please, sir.
It is exactly 12 o'clock, and the time I can take is only 40 minutes, right?
No, sir. It's a 1.5 hour session. We have it from 12 to 1:30, and
Yeah.
then in the last few minutes, we'll have a question and answer session if the
Okay.
participants have. So you can take as it is convenient, sir.
Yeah.
As
Okay.
you're
Then it is now 12 o'clock,
yes, sir.
and I can continue up to at least 1 o'clock. Is it?
Sure,
Yeah. One
sure,
or
sir.
1:15. That's a
Yes,
very good time, and I can go very slowly, neatly, without much hurry, worry, right?
thank you
So,
so much.
so exactly. Good afternoon to everybody. Past 12. And first of all, I must thank the organizers for calling me and share my ideas on the water management in sustainable development and planning. I believe you are all architects, future architects of this country. So a lot of role you have to play, particularly when it comes with natural resources. One of the most important natural resources to survive on this planet is the water. So if you manage water, then you are well to do with. There was a old custom in our families also, particularly in Telugu states families, when there was a they want to make alliance for girl and then boy. The the groom, when he comes to visit the bride's house to see, so they normally they give some water, you know. Suppose if the groom's party adjust with the water they have given, that means this boy or the family is well to do with. That is how our old tradition. That means water management is age old, and we have within our tradition itself. But then, with the modern thinking, modern practices, and then modern kind of things, there is a lot of disturbance to the natural ecosystem, and we have to adjust with our development, adjust with our environmental requirements, adjust within our own personal management, our goals. So, can I have a next slide, please? Next slide. Yeah. You can see water provides a powerful medium for it acts as a medium. For example, you can see when your entire body weight, more than 80% of this the matter constitutes with water. Not only that, when you have, for example, you have a Musi amidst the, it is cutting across the Hyderabad city, I mean, making it two halves. You can see when monsoon comes, much of your pollutant is washed and carried down. And much bigger cycle is these great rivers like Krishna, Godavari, the Brahmaputra, Ganga, they draw sediments from the higher reaches and then deposit in lower reaches. That is how the great deltas, like present day delta, Godavari delta, Krishna delta, Ganges delta, they are the food bowls of this country. The deltas were formed by the movement of water. What water has made? It has made all the materials. That means the very fertile material from the upper reaches and then moved it to the lower reaches and deposited. So like that, we can imagine this movement. It's a medium. It is a water provides a powerful medium for the natural transport of materials and pollutants. Even pollutants also, it is washed away. All your sins are washed away during this monsoon. You can see water is circulating through air, through the ground, and through the life bodies. Provides a connecting link for all. We have been connected right from the atmosphere to your inner body. It's not just that water is a some kind of material. If it is good, you're well and not. No. See, during the monsoon time, water is being transported. I mean, moisture is being transported across the continents. Even your bacteria, viruses come with this. Many of you may not be knowing. So even sometimes it is across the continents, not just nearby. That's how the monsoon water comes in. Is that total water is constant? Some many, people say asking, sir, water bodies are drying up, groundwater is, entire groundwater is withdrawn. What is happening? Is it really water is constant on this planet or not? Scientifically, we should say the total water is constant on this planet. Nobody can destroy a molecule of water, or nobody can create a molecule of water. Okay. Then the next question is, why do you worry? When water is constant, why do you worry? This is, we are not worried about whether entire water gets evaporated from this planet Earth, or something like that. No, we are worried about its form, its quality, its quantity, and timely availability. It is important. Suppose, imagine that entire rainfall occurs only on the oceans, not on the continents. What do you do? All our oceans are saline water. You get fresh water only through the rainfall, is it not? So, by our actions, due to some changes, maybe we call it as a climate change or some other change, natural changes, this monsoon or the rainfall disturbs the natural patterns. Already you are having your own pattern of rainfall. For example, in Sahara Desert, they don't have a rainfall. I think some of the people they have not seen for the next 20 years. In their lifetime, they hardly see few rainfall occasions. Such is the thing. Today, we are here in Hyderabad. Almost every day during monsoon, we are getting rainfall, particularly this year. So there is a huge change. Total water is constant, but its form, in which form it is available? Is it in a ice form? Or is it in a liquid form? Is it in a vapor form? Its quality, whether it is can be drink or we cannot drink it, and its quantity, is that the entire irrigation to do, is it sufficient or not, and its timely availability. As and when it is required, we want water. See, suppose I took a 1 glass of water now, I don't require for the next few hours. But when it is required, it has to be available. So this is a whole gamut of management that is in the water in this environment. It's not just water. It is a blue planet. Of the all the planets in the solar system, it is the only planet having water. No other planet is having. That is why the life is possible. In other planets, there is no water, there is no life. Of course, definitely we are having a lot of space exploration nowadays. We are searching for those planets which are having at least some amount of water, or past they have water. Like that, we are searching on Mars and other things. Even in the extraterrestrial bodies also, that is a different issue altogether. Okay, let us go for the next slide. Next slide, please. You can see this is the hydrologic cycle. I think unfortunately I could not play from here. So the water evaporates from the seas. You can see the ocean to my right side. It is a ocean MSL. It is represent mean sea level, and this ocean, huge amount of water is evaporated due to sun's energy. Not only from ocean, even from the continents. You can see there is a continents up and down topographic elevations, and the trees from the many bodies within on the land, on the ocean, on the land, on the ocean, and every minute, every second, the continuously, due to sun's energy, water is getting evaporated. You ourselves also, while I am talking, I am exhaling lot of soil moisture. I mean, not soil, a lot of moisture. So like that, trees, they also give lot of water. When they suck water from the ground and then release water to the atmosphere, that is called evapotranspiration. Evaporation from the soils. So all this moisture goes up to the atmosphere, and after all, this is a moisture, and whenever it find, that's how you see in the form of clouds. Cloud gets formed. This is simply moisture. Whenever you are going on the flights, you are cutting across these clouds and they're going. Okay, your visibility gets reduced. Even on the ground also, many times cloud comes, your visibility gets reduced. There's like a mist. So when this is in the vapor stage, then when under suitable circumstances of under some temperature and pressures, this water vapor becomes liquid and drops back into the land. So that's how it rains. These rains will occur as and when there is a sufficient cooling in the upper atmosphere to cool this vapor and then convert that into a liquid and then drops back into the land. Again, evaporation, transpiration, and all. So the fallen water, some of it goes to the ground, some of it just travels on the surface, some of it held in the soil. So that is how these rivers are created. That is how the groundwater is created. So all these things, it's something like a cycle. Everything is a cycling, a recycling. There is nothing like we can create even a single molecule of water. Oh, everything is recycled. That's why I used to tell to my students, a molecule of water in your stomach might have been circulated through the dinosaur's stomach. If this is the concept we should extend, then why do we feel something like resistance, show resistance that if the water is reclaimed from wastewater, from the cities, so much of water is, sent as a wastewater. You see in the Musi. So like this, lot of water is being wasted. You have to recycle it back from the cities with appropriate water quality. Today we can recycle it to the drinking water quality. Absolutely no problem. Technologies are available. So recycling we must learn and live with to sustain these cities. We cannot bring the water far away. I will show you sites later on. Okay. So let us have the next slides. Next slide. This is just a glimpse of the old water resources. Of course, don't bother about that big figure, but look at the top, you can see. But 97.2% of water is salt water, that is in the oceans. So you cannot use it. So though it is a blue planet, everywhere, water, it consumes water so much, but most of the water, we cannot use it. Of course, that water nowadays, you can with RO and all for drinking, we can make it, but it's very expensive and all. But for a regular use, like great irrigation use and then many other drinking use or other uses, you cannot directly use that salt water. So what is the fresh water on the surface? It's just 2.2%. Out of which groundwater is only 0.6%. But the total fresh water, out of the total fresh water of it, most of it now is in the glaciers and ice caps. 2.15% is in the glaciers and ice caps. That means most of the fresh water is in the glaciers and ice caps. That means the north or the south polar regions. Of course, Himalayas are also called one of the pole because its height and then glaciers are there. Of course, these glaciers are getting melted, but still much of the fresh water on the surface of the earth is in the glaciers. But you can see now, what is water that is just available in lakes and reservoirs, so-called rivers, so-called in great dams, reservoirs, canals, everything put together, it is just only 0.01% of the total water. Whereas in the ground, it is 0.3%. That means, in fact, the fresh water much lies below the ground surface compared to the surface water, almost 37 times it is. But you cannot extract all that groundwater. Present utilization of groundwater is just only 1/5 of the total utilization. And now, just instead of going through such a huge statistic, some of you might have understood, some of you are not, some of you are confused. Just for a layman to understand, suppose if you assume that 100 liters of water is there on the surface of the earth, just for a small calculation, how much you can use it is totally just less than half a teaspoon. That's all. That is why we are worried. Though there is a lot of water on the surface of the earth in the form of oceans, glaciers, and so many, but only hardly very small amount of water is usable. That is what, that is where the management comes. Why we are worried? Its form, its availability, timely availability, this and that. Okay, okay. Next slide, please. Next slide. Yeah, this is a in total India's water resources. Mean annual rainfall, we have a huge variation. Just 1,100 mm somewhere in Cherrapunji. Of course, Cherrapunji is no more the highest rainfall. Normally, we learn from the other textbooks. The place has been changed now. Okay, sorry, 11,000 mm in Cherrapunji, not 1,100. 1,100 is our average annual rainfall of the entire country. But it varies from 11,000 mm somewhere in northeast to just less than 100 mm in western Rajasthan. You can see such a huge variation. It is not uniform throughout the country. So that is why we need water management. We have to transfer the water from somewhere where the water is under floods. Even northeast gets floods. Whether we can transfer from there or not, that's a different issue. The Ganga basin, there are some floods. Even in Godavari, floods are there. Any river basin, there are some floods. There are some droughts. So it's not uniformly distributed. So that is why there is a huge variation within that. The spatial distribution is not uniform, the rainfall. If the spatial distribution is uniform, there is no need of any reservoir, there is no need of any something like supplying out. Everybody gets equally, and then they can simply have a small storage structure and then utilize. That is why we need dams, that is why we need structures and so on and so forth. Okay. So anyway, let us go further. The total geographical area of the country, 329 million hectares. Previous slide only. Yeah. And then out of the total rainfall occurring on this Indian land mass, if you just multiply that height into this area, you will get the volume. How many kilometers cube of water it is falling every year? 4,000 km cube, kilometers cube of water is falling on our land. So out of which 75% of which is just within 3 months of monsoon, 3,000 km cube. 75% of the rainfall just drops in 3 months of this monsoon. Okay. So this is where the management is required. We have to catch this rainfall through either river systems or recharge to the groundwater or some other. Okay. 1,880 km cube only, just less than half only that is flowing in the river system. What is happening to the remaining 60%? It is going something as a groundwater recharge, something as an evaporation and transpiration back to the atmosphere and so on. Anyway, that is how it is circulated. Then total utilizable water resources of this country is around somewhere 1142 km cube. You cannot utilize all that river water, which is 1880 km cube, because Brahmaputra, for example, flowing at a very high elevation, you cannot really tap it. Similarly, in Western Ghats, many rivers you can really tap it, because all they flow towards the Arabian Sea. Okay, so surface water, out of this surface water is around 690 km cube. Groundwater is 453 km cube. This is how we can tap this water. And ultimate irrigation potential, of course, may not be that much of interest to you, but is somewhere around 113 million hectares. From groundwater, you can get almost half of it, 58 million hectares. So in a sum up, you can see here, India has around, I think now its share is much higher, 17% now. Most probably this statistic way back many years I have prepared this slide. Okay, it is somewhere India has having a population of 16% of world population, while having only 2% of land and 4% of freshwater resources. So we are carrying the burden of 16% of the world population, but we are just having a natural resource of 2% of land and 4% of freshwater resources. That is why there is a huge pressure on water and land resources. That is where your planning is required. You architects, plans, so many things, but this is the fact. Already 60% of groundwater has been developed. See, this is another important statistic. We have developed more than 62% of groundwater. In fact, of course, I have not included here. I tell you, India withdraws groundwater much more than the China and America put together. Almost we extract one-fourth of the world's groundwater. One-fourth of the world's groundwater extraction. Our extraction is, whose quantity is equal to one-fourth of the total extraction of the world. So that is the thing. Anyway, so let us go further. Next slide, please. Yeah. Compared to average annual rainfall of Saudi Arabia of about 150 mm, our rainfall is much higher. You can see in Saudi Arabia, what is our rainfall, how much? Just now you have seen 1100 mm. Many times, but they are also living much with higher standards. Of course, with this desalination plant and all for drinking, but other things, they are managing the water. Israel is also same, almost similar amount of rainfall water. Whereas you are having 1.21 meters height of water above your entire land. But of course, most of it is in monsoon, no doubt. Definitely, this calls for storage. Okay, we have to save the environment, no doubt. But yeah, for those people who say, no, dams will spoil the environment, I cannot unfortunately agree here. Dams, yes, do spoil some kind of disturb environmental balance. But here in our case, in case of India, there is a necessity of storage. But here, the storage can be in a smaller storage structures or bigger storage structure. That is left to you. So that is why storage is needed, because your entire monsoon gives you 75% of the total rainfall. Now, as per the international norms, per capita availability of water, this is how. Suppose if it is a 2000 meters cube, then you are coming to a critical position. If the availability is 1000 meter cube, very low availability, then 500 meters cube, critical lower limit. So this is a per capita availability of the water. Let us see how we fare, where we are. Next slide, please. Next slide, please. Yeah. Oh, I think you might have skipped one slide ahead. I think one slide ahead. This. Okay. Go ahead. Next slide. Yeah. So water allocation priorities in national water policy. Earlier, 2002, let us compare 2012 national water policies. Time to time, the government of India, of course, water subject is a dual subject, concurrent list. Both states as well as the center. That means the state governments as well as the Indian government has the jurisdiction on the water. But state governments can act only within that their state water resources, whereas central government has the overall control. Whenever two states fighting each other, they come into picture, and they can also fund and everything. Anyway, then drinking water irrigation. You can see that main headings of policy of 2002 and then 2012. Earlier, we were bothered about quantity allocation. That is mostly like a supply side management. Whereas in National Water Policy 2012, many new concepts have come. Of late, Water Framework Law, then adaptation to climate change, demand management. Instead of supply side management, we have a demand management, and water use efficiency, water pricing, preservation of river corridors, rural and urban water divide. So there is a huge policy change. Now, earlier we used to supply whatever the water, we used to plan, we used to construct dams, we used to do so many things. But now we have to do all these things under the framework of a law, and then the environment, and then efficiency, how much efficiency you are using, and then how much you are preserving our environment, and what is urban rural divide, and so on. Of course, I can give you only almost 1 hour lecture on this, but let us go further. Okay, next slide. This is a very I think just see the most blue color represent the highest rainfall over our country. My cursor I could not whether you can see it or not, I don't know. The Western Ghats, very high rainfall, that is a Western Ghats high rainfall zone, almost 300 mm. This is the northeast and the Ganga basin and Mahanadi basin, and parts of Bihar, Jharkhand, they also got a high rainfall. Whereas you are somewhere here in Hyderabad, you are in a rain shadow region. So your rainfall is somewhere around 700 mm to 800 mm. And most, see how this Indian landmass gets rainfall. There is a monsoon coming from, there are two types. One is during this season. So a southwest monsoon. This is the south. This is the south. The southwest monsoon travels across the India. One part directly dashes the Western Ghats. Other part just take a turn around and travels across the eastern coast and travels up to Himalayas. So that's why in the Western Ghats you will receive maximum rainfall, and as another part, as it travels across the mainland mass, and when it touches the Himalayas, then in the Ganga basin you will have a rainfall, and even central India also will have a very good rainfall. Because of this Western Ghats, much of this central Deccan plateau, which is having a rain shadow, that means less rainfall. This is how we understand. And of course, the Western Rajasthan is also having a very less rainfall. This is a Thar desert is the continuation of the desert of that latitude, right from the deserts of the Middle East and so on. Okay, let us go further. Next slide, please. Okay, you need not bother much of all these figures. Only per capita, surface and groundwater put together, how much is available in each basin. The highest basin now available is at least now Brahmaputra. But Brahmaputra, we cannot use this water properly because it is flowing in a very high land. And of course, the next one is in Godavari. But even Godavari upper reaches are very much stressed. But most of the river basins, as we have seen, less than 200 meters cube per capita availability is critical. Most of the basins in India are already under critical stage. Average you can come is more than critical, but whose average is total. But at a particular place, for example, even in Godavari basin, upper parts is highly stressed for the water. Okay, so next one, next slide. Yeah, average is around 2,731 meters cube in the overall India. You can say it is not stressed. It is not comes under critical, but all that is not happy everywhere. Somewhere something less, even less than 100 meters cube also. Okay. Anyway, so this is the situation. Next one, we have to charge up. Next one. So much of the water is concentrated in Brahmaputra Barak basins, which you cannot really explore because it flows in a very high elevated area and joins in Ganga. It is much lower than that. That means in Bangladesh, and then a lot of flooding is created. But today there are technologies to tap. People are trying, but anyway, that is a far away. Total utilized water resources 690 kilometers cube out of 1869 what we have that is flowing in the entire rivers. Present utilization is only still 174 or even little bit more, around 200 km cube. So you can see out of 690 we are utilizing only around 200. Much is not utilized, still flowing to the great seas. Even in Zambia, Zimbabwe, one single dam stores around 180.6 km cube. All our storage put together. Even Egypt Aswan Dam, it stores around 162 km cube. So we are still storing very little less. My dear friends, please understand. Even in the less stressed basins, upper reaches are stressed. Just now already told. Of course, in some places, Assam or other places, more water is a problem. So next slide, please. Next slide. Yeah. India can store still only a relatively small quantities of fickle rainfall. Why we are calling fickle rainfall? The entire rainfall occurs just in during monsoon days. Even those during monsoon days, see, for example, in places like Hyderabad, you know how many rainfall days? It is only around 40 to 50 rainy days out of 365. You know how many runoff days? Hardly less than. Runoff means when rainfall occurs, some water is flowing in a nala or river or whatever it is. That is called runoff. You can count on fingers. That is the runoff days. Okay. Anyway, next. US and Australia can store around 5,000. I'm sorry, not next slide. US and Australia can store 5,000 meters cube per capita, just for comparison purpose. Mexico, China, these are all middle income countries. Even China now developed even better than South Africa sometimes, Mexico. So they can store 1,000 meters cube. So developed countries storing around 5,000 meters cube per capita, whereas middle income countries 1,000 meters. But India is still storing only 200 meters cube per capita. So there is a lot of scope, whether in the form of rainwater harvesting or in the form of construction of small or big dams, whatever you want to do. I am not advocating for big dams or small dams. Only thing is you have to store, you have to catch, the rainfall. Okay, there is a every indication that need for storage will grow because of global climate change. Now you are saying about climate change. What is the climate change? Entire summary of this climate change. In future, you please listen carefully. As per the climate projections, in future we are going to have more floods and more droughts also. That means the so-called highly concentrated rainfall spells are going to increase, and the so-called gaps, droughts and other things. That means rainfall gaps within the monsoon. 2-3 days you have a heavy rainfall, and the next 20 days you may not have any single drop. Okay, they are all going to increase. So these are all, and then glacial melting is also occurring, and there is a sea level rise because of the glacial melting, and salt water intrudes into the natural groundwater aquifer at coastal regions. There are, of course, is a very big subject, and so on. Okay, next one, please. Okay, this is a of course geographical area of the country, already 322 million hectares. We have a very good cultivated area, 188 million hectares. You can see when compared to the world, most of our land, 60% of the total area is we can bring into the cultivation. Whereas in USSR, combined former Soviet Union, just 10%. Even UK, 29%. US, 20% cultivable area. And China, just 10%. So the India is blessed with, that's why it is supporting such a huge population, and a lot of cultivable area is there. So crop land at present, it's only a little bit more than this, maybe 150, 160 million hectares. Present area under irrigation around 100, maybe might have been there. I think likely irrigated area, yeah, almost we are approaching 2025, 100 million hectares. But total utilizable water resources is only 114 million hectare meters. You cannot utilize more than this. Already I told, because of various reasons. Present utilization is still around 60 to 70 only. It's not that much. Still we have to utilize these water resources. So required water by 2025 is 105 million hectare. Already we are at 2020. So that means it. Next, please go to the next slide. Meanwhile, I will tell. So we are going to have a very huge water storage. We have to do it, and then irrigate, and then produce the food. Achha, present population of the country, it is not 1,000 million now, 1,300 million now, and that means 1 billion plus 1 billion 30 million now. So the population already estimated, they have estimated 2025, but we have crossed already this one. Okay, so like this, when you are estimating, go on estimating like this, we need to produce. Now we are producing around just little less than 300 million tons, whereas we required by 2025 around 350 million tons. And present our status of food production per hectare is irrigated area around 2.2 tons per hectare, which is less. At, of course, at Punjab, they are producing more than 4 to 5 tons, whereas on average it comes to 2.2 tons. Whereas this is very important figure, 0.75 tons per hectare for unirrigated. Why I am telling this 0.75 figure is important? Still, even if you harness each and every drop of our water, I mean falling water, you can provide irrigation only to the 30% of the cultivable land. Remaining 70% of the land is under rain-fed only. This rain-fed irrigation is very much important apart from the irrigated land. So that is why unless you increase here under a rain-fed, you cannot meet the food production. Okay. Okay. Let us go to the next slide. 80% of world fresh water is used for producing the food. See how much water we are utilizing for producing the 80% of world fresh water. For example, if you are eating a kg of rice, means you have to use 1,000 kg of water or 1,000 liters of water. Okay, so if you are a t-shirt takes 4,000 liters of water to produce, get it produced. So this is called virtual water. What is a green water? Water in the soil is called green water, constitutes 70% of the fresh water used for producing the food. Most of the soil water used for producing the food. Blue water that is there in the rivers and aquifers, it constitutes around 30% of the fresh water used for producing the food. Of course, gray water is the wastewater. That's what virtual water I told. 1,000 liters of water is required to produce 1 kilo of staple food. Okay, this is how the water, present water footprint of the human beings. Next one, please. Now you can see the rainfall of the country over a long period, 1872 near 2000. Of course, even further graphs also there. By and large, over a period of so many years, more than 150 years, the average rainfall is not varying much in India. This is all India summer monsoon rainfall anomalies by Lal 2001 produced a paper. So then what is happening? Next one, next slide, please. Next slide, please. You can see the river basin wise what is happening. Indus, Brahmaputra, Godavari Mahanadi basin, west coast, Ganga, Narmada, Tapi. If you can closely follow, just look at that red line where it is steeply falling. That means where the rainfall is getting reduced. You can see west coast hooping minus 10.94 slope. That means the Krishna, Godavari, Kaveri rivers origin is from the west coast, where the rainfall is getting slowly decreased. Yeah, on average in India, it is by and large the same. Whereas in the west coast, it is because we have spoiled a lot of the west coast ecosystem there. Of course, Krishna little bit decrease. In fact, entire peninsula, if you see, a little bit increase in rainfall, entire peninsular India. That means in the middle of the India, you have the next figure, you can see much a little more clearer. Go to next figure. Yeah, you can see this is a projection from the modeling spatial patterns of the changes in summer monsoon rainfall for the period 2071. That means for the future to 2100 with reference to the baseline of 1960 to 90. These are the this is the medium scenario. This is the Indian Institute of Tropical Meteorological Study. You can see, fortunately, the central India, that means the Krishna Godavari basins receive more rainfall in future. That means you will receive more floods in Krishna Godavari and much more dryness in western India, that is Rajasthan, parts of Punjab, Haryana, and even Madhya Pradesh to some extent. Okay, but unfortunately, this western ghats of Kerala and Karnataka and most of the Kaveri basin, it is getting less rainfall. So this is our future, and northeast also going to get less rainfall. Sorry, northeast not so much change, but it's okay. Next one. This is what is known as extremes in monsoon. Just now we are discussing. There is a extreme events are increasing. Droughts are also increasing. Floods are also increasing because of climate change. I need not read all those. Okay, next one. Next one, please. This is what is our using pattern. See, the blue line, which is known as a groundwater. This groundwater goes on increasing. You can see blue line. Whereas this pink line, which is a surface water, we are not able to tap much of the surface water over the years, though we are constructing this way, that way, so many dams, this and that. But some of the dams were silted up, and in fact, the runoff has got reduced, and the reservoirs capacity has also got reduced. But overall, that maroon line goes on increasing. That means in the last 3 decades, whatever the water we are drawing mostly from the groundwater, not much from the surface water. This is a very interesting statistic. If you whether you believe it or not, much of our groundwater has been utilized. This is not good for the country. This is not good for the environment. This is what we try to inform you. Next one. Next one, please. Yes, 30% of India's power used just to pump the groundwater. Lot of subsidies given to the farmers without any power bill. The pump can be connected, and then they are pumping. Power utilities become bankrupt. Of course, those figures are very, long back. Now, because of this power, what did the government say? We'll give the power bills, but they don't give to these discoms. So they get into the losses. So this booming groundwater economy, that is not correct. We have to save this groundwater. By how to save this groundwater? By reducing the consumption in agriculture. How do you reduce the consumption in agriculture? By adapting to high water efficient methods. If you just save around simply 15% in the agriculture, that means irrigation, you can flood the entire cities like for drinking water. So intelligent power supply pricing needs some kind of management here. Next one. Next one. Now coming to your sector, urban water and supply. Most of your planners are working in urban India. Rural India, less number of planners are working. But anyway, let us see this population figure in millions and the urban population. See, many of you know better than me, you know much better, our urban population are increasing. So more than 50% of our population going to live in big cities. So what is happening? What is its effect? Its effect are traditional sources are sinking. That means even take the Hyderabad. Once upon a time, Meralam tank was the source for the drinking water. Then we have gone for Hussain Sagar at the midst of the city. Now it is no more a drinking water source. Then we went for the Himayat Sagar and Usman Sagar. They have also very small amount they are providing. Now we went for Manjira, we went for Krishna, we went for Godavari. So traditional sources are sinking as the population is increasing, as the city is increasing, and we have to bring the water from very far off places. That is the result. Next slide, please. Yeah, you can see Bangalore getting water from more than 100 kilometers away. Ahmedabad, River Sabarmati, 150 kilometers. Delhi, like that. Even Chennai, they are getting drinking water from Telugu Ganga, 400 kilometers. You imagine the impact of this. Yeah, okay. Mumbai is lucky; they are having a better source there. And when you are bringing water from such a large distances, what is happening? Even by just leakages and at the tap, most of the water is wasted at the tap. 20 to 40% of the water brought from such a large distances are being wasted at the house. Why we not fit proper fittings to make this water more efficient for utilization? It's a foam like thing. If you get from your tap, there are fittings like that. We can save much water. Okay. Then when you come to the recycling of water, it is very paltry. Mumbai is not at all properly recycling. Maybe these figures has to be upgraded, but because they are throwing, because very nearer to the city. Delhi is much better, but still not up to the mark. Chennai also not good. Hyderabad also not so much. We are just Hyderabad, less than half of our sewage is being treated, and we are putting back into the service. We are not putting back into the service. We are simply leaving it to the ground. So here is a lot of scope to save the water by recycling our waste. Okay, this is very important. Next slide, please. 120 liters per capita per day in the urban water supply. This is what our central agencies use for supply, but it is a little bit higher also, I feel. When I also calculated at my household, we are taking around 80 to 100 liters. Then what is happening is 20 to 25% of treated water is wasted. That is how, due to pipeline leakages, altogether 30 to 35% is wasted. While the major drinking water pipeline is running through several localities, villages, because we have to bring water, our Krishna pipeline coming all the way from Nagarjuna Sagar to Hyderabad. So many places it gets, people simply pierce it and then tap the water. So this is how, if you don't provide drinking water to that particular locality, then they will attack on your pipeline. So this is what is happening. Next one, please. Next one, please. Yeah. 1 out of 3 in the developing world lacks access to still safe drinking water. But today, the situation is much better. It is overall the world. In India, we are having now we have accessibility rate has been increased, and 2 out of 5 lakh sanitation, resulting in 10 million deaths every year. We are talking about deaths due to coronavirus, deaths due to cancer, but the sanitation is still not good. 2 out of 5 lakhs, 2 out of 5. If there are 5 people, 2 people lacking sanitation, proper sanitation, resulting in 10 million deaths every year. It would take less than 5% of the world military expenditure to meet the basic water and sanitation needs. So this is how. Let us go to the next slide, please. Next slide. Issues: water leakage from houses, particularly from overflowing sumps. My dear friends, you are having all some permanent, your own houses. Many times your sump filled and gets leaked to the road. They don't even bother to connect, having a small float, damaging the roads, and we club the drinking water requirements and other domestic uses. See, we are using the same water both for drinking as well as other domestic, including washing of car, washing of corridor, and many other things. That is not the wise one. Then urban flooding, basically due to choking of drains. Even nalas are choked, all these drains are choked, concrete cover of the catchment, occupation of water bodies. Many of these water bodies in the city now, earlier they used to hold some water, but they cannot hold now because most of it is being occupied, and water is let out. That is why you are having flooding. Needs to revisit to the drainage design. Drainage design has to be, we have to upgrade, we have to rethink it in view of the urban flooding and because of climate change and so on. Next one, please. You can see there is a quality problem also. Of course, I cannot concentrate now quality problem because lot of water, groundwater particularly, is being polluted because of either nitrate pollution. Nitrate pollution is a very, very widespread. Naturally, fluoride and arsenic, that is the cases, everybody is know. I don't want to concentrate. But because of more urbanization and more utilization of fertilizers, nitrate pollution is one very important. And, blue baby syndrome, and even the holes in the heart if you drink water. with the nitrate high. Normally, nitrate should be less than 40 mg per liter. But now everywhere it is 80 mg per liter. This is a very dangerous signal. Okay, next one. Next one, please. Oh, you can see how the groundwater we are pumping. We have a digital water level recorders, and it is water level. That red line is going down. Okay, next slide, please. We can catch it up to the time. And this is very important figure in my own office at JNT University Hyderabad. How the recharge is occurring. You can see the graph. The red line is goes on increasing as the monsoon is coming. So we are getting a very deep water, but it is getting recharged. There is a huge potential for recharge. Every house must have a recharge pit. How many of you are having houses? Sorry, how many of you are having recharge pits in your houses? Very few. In every meeting, if I ask this, hardly less than 10% they are raising their hands. Of course, virtually I can ask you, how many of you are having recharge pits in your own house? Next one, please. This is what the variation of annual rainfall and monsoon rainfall. Already we have discussed 75% of rainfall is just only during these 50 days of rainy days in the monsoon. So you have to catch this rainwater harvesting. We have to. This is yeah. Go back. Yeah. Right. Keep it. So you can see we had a very one of our in our project. We have picked up the samples all along the groundwater along the Musi. And you can see urbanization, how it is reflecting. TDS is increasing as and when you are coming to the urban world. You can see this is outskirts of Hyderabad, that is Vikarabad, Chevella, this area. The moment we enter, somewhere it is Ramannapeta, Rajendra Nagar, then TDS is shooting up like anything. And entire city is over, then there is a TDS is falling. That means by urbanization, you are polluting very much. In between, there are industries, you are polluting much, and again. So this is the baseline, this side and this side. In between, you are simply polluting. That means you are giving a heavy load to the groundwater pollution. Next one, please. Please change the slide. Yeah. Not only small, simply TDS increase, heavy metals are also increasing. For example, it is how it goes. First, it embraces the soil, and then sediment in the lake, and then it reaches the groundwater. But what is happening? While in the soil, it's a limitation to certain parts only. In the sediment also, certain parts only. But when it reaches the groundwater, is very wide spread. This is what is happening. So on the soil, when you just throw some waste on the soil, you think that, okay, soil will eat away. No, it just pass on to the groundwater. Okay. So the groundwater is highly widespread. Next one. Even the lead distribution you can see, zinc distribution you can see. Next one. These are very dangerous, heavy metals are getting polluted. This area you can see how in a pictorial form, directly they are reaching from the surface pollution to the water table, or they can run to the nearby stream, water body, and then to the groundwater table. Okay. So that is how a lot of heavy metals also know. Heavy metals are very dangerous, and you will be getting with cancer. Cancer cases gets increased. So this is the problem. We are increase of cancer hospitals also, cancer patients also. Okay. Next one, please. That is a dumping of waste on the soil, and then directly it is going to groundwater, surface water, and then sediments. This is a pathway. Next one, please. Next one, please. Yeah, need for artificial recharge. This is very important, where you can plan the to overcome the inadequacy of water to meet our demands. Whatever the water that is going as a runoff, you can just simply catch and then arrest and then recharge to the ground, particularly in the cities, because you have already seen pollution, lack of sufficient quantity, quality. So all these things we can arrest, we can aid, all these things we can arrest, and we can aid in supplying the quality water by recharging artificially. To enhance availability of groundwater at specific place and time, utilize the rainwater for sustainable development. To increase the infiltration of rainwater in the subsoil, which has decreased drastically in urban areas due to paving of open area. Many of the places, we are concrete, we are making it a concrete jungle, and we are not allowing the water to seep it down. Okay, so what is needed to improve groundwater quality by diluting it? If you send more rainwater into the ground, you can dilute that groundwater which is already contaminated, but you can utilize it later on. To increase agriculture production, that is also there in rural areas, to improve ecology of the area by increase in vegetation cover, etc. Normally, what we are thinking, we are alone living on this earth, but along with you, there is so many creatures living. Groundwater, surface water needed by you alone. You are so many people. So many creatures. Okay. So advantages of artificial recharge, cost of recharge to subsurface reservoirs is very lower than the surface reservoirs. The aquifer serves as a distribution system. See, when you are recharging the ground, it spreads in a very wide area. It is not just in one location. No land is wasted for storage purpose, and no population displacement is involved, and groundwater is not directly exposed to evaporation. These are some of the advantages if you are recharging it. Next one, please. Next one. Yeah, storing water underground is environmental friendly. It increases the productivity of the aquifer. Once upon a time, your borewell is not functioning properly because there is no water table. Now, if you are recharging, if you bring water table up, your borewell gets function. It reduces the flood hazard. Urban floods can be reduced. Effects of rise in groundwater table can solve many problems, mitigate the effect of drought also. During the drought period, you can use this groundwater back, reduce the soil erosion also. Many times soil erodes and you are losing the important soil. Okay, methods of techniques for recharging. The methods of groundwater recharge in urban areas are mainly rooftop rainwater, storm runoff, harvesting through recharge pit. I was talking about recharge trench. These are the different names. The fundamental principle is to recharge. Tube well also you can recharge well. Community recharge bits, this is also very important. So far we have not started. Recharge through bore wells in lakes and reservoirs. Next one. Yeah, these are some of the figures approved by Central Groundwater Board, which you can think and provide. You can see each house is having a rainfall water rooftop. There is a pipe taken from the rooftop, and it is put into some kind of recharge pit, where in the pit you have arranging some kind of gravel and rubble stone and sand, like that. We can discuss further these things. Next one, please. This is one model. It's not necessarily always this model you should adapt. This is a example of, you can all along your site, if your site is bigger one, you can recharge all along your site. Recharge trench. This is called recharge trench. Earlier you have seen recharge pit. These simple things you can adopt in your households. Next one, please. Next one, please. Yeah, this is a apartment sites also. Many of you are designing apartments. You should necessarily have a recharge, all the bigger recharge pit here into a smaller desilting tank or some kind of treatment, and then put into a borehole, deeper aquifers. You can recharge. Very simple techniques. Of course, in 2002 Volta Act, we have made all houses 200 meters and above area, square meters and above, you must have a recharge pit. If you don't have, you should not be given even current, that means electricity connection or water connection. But we are not following. We are making planning, but we are not following. That's the problem. Next one. Next one, please. Yeah, this is another thing. In a very, very big complex, you can have a recharge well. This is how there is a filter here, and then two wells you can recharge. These are all some models available in the CGW website also. We can provide also, no problem, this kind of things. Okay. This is I am simpling. Way back in 1990s, I have presented a paper in Stockholm Water Symposium. It's simply, if you can maintain all your water bodies in your city as a freshwater bodies, and you can make a small boreholes here, provided this should be a freshwater body, you can recharge huge amount of water. But unfortunately, we are not maintaining this as a freshwater body. They are all dirty water. This is one problem. What we have to do? Yeah, this is what this. Yeah, what? Okay, use the previous slide. You please go. Previous slide. Yeah. What we are doing is we are filling this all with filthy water. Unfortunately, we cannot recharge. Okay. So you can use even you can arrange some filter here also for the silt and other things or another unnecessary some kind of urban pollutants. Still, you can recharge. How many lakes are there in the city? But they are all unfortunately filled with bad water. Next one. In Hyderabad, next one, please. In Hyderabad, we have a very recharging environment also. You can see this weathered thickness and fractured thickness extending up to more than 100 meters. In fact, lot of groundwater is pumped because of this. Now you are pumping more than 300, 400 feet. That means more than 100 meters. This upper layer is already evacuated. That is weather layer. Normally, we should pump from here only. But unfortunately, there is a water table has gone down. You are pumping from here and you have to recharge. There is a lot of scope for recharge because of this weathered and fractured environment, particularly though it is a hard rock. Normally, we believe that it is a hard rock which it cannot yield, but there are a lot of fractures which can yield. Okay, next one. Next one, please. This is what the recharge pits. So many people they construct recharge pits, even the central HMWS and SB. They don't leave sufficient space between this fill up and the top. See, in your house, if you are constructing recharge pit, follow this design. You can have whatever the little bit area, whatever available that, but you have to dig it up to around 7 to 8 feet. Fill with that bottom 3 feet. Bottom on last layer is 30 centimeter thick. Sorry, coarse aggregates. That means when you are putting some foundation, a bigger size stones, then followed by a gravel. This is a 20 gravel for slab and all use. Then followed by a coarse sand. This is how medium we are arranging, and this should be around 3 to 4 feet. Remaining at least 3 to 4 feet, there must be a gap. No, without looking like this, they are all filling up to brim. What is happening when this rainwater comes? It is simply passing away by filling this gap and then going away. But it should be stored. There must be storage facility. Side walls you can build. You can have a manhole cover and so on. Within your house, it hardly costs less than 20-30,000 rupees. In fact, the government of Telangana and even Andhra Pradesh earlier, they were giving some concession also for this. You please build these recharge pits. Okay, next one. Yeah, you can see some of the recharge pits they have built. This is the slope of the land. This is how our planning is so bad. They have built a recharge pit here. That too up to filled with the top. What is happening? All the water flowing down. Not even this pit is. I have taken this photograph at my colleague. There is not at all filling. What should be there? The pit should have been constructed somewhere here. Okay, next one. Next one, please. See what is there, how much they are filling. Simply water, first of all, it is not entering. And everything is filled. And if it is a smaller rains, it's okay. But it's a bigger rains, this if it is simply get filled because the infiltration capacity is not much compared to the rainfall intensity. So it goes away. So these are some of the lacuna in recharging. Many times I was the member of the committee constituted by the Honorable High Court. We have given recommendations also. These are the how much is the top area, rainfall is how much, rooftop area is this much, harvesting water from rooftop, how many cubic meters. All these details are given from the CGWB website, Central Groundwater Board. You can just download. You need not bother about these calculations also. You can just, it's a intuition. By intuition, you can just have a construct the pit, direct all that rooftop water at one corner and then recharge. So this is just I have shown how you calculate pit volume calculation. Maximum rainfall you can resign only for 120 not more than that. House plot size, let us say 200 meters square. The total volume of rainfall 200 into 24 meters cube. So then you go accordingly the design of the volume of the pit. But I am asking, you must leave some volume for storage. Otherwise, your pit will get filled. If you cannot fill the pit till the brim. Okay. So maintenance, yes. High quality water can be recharged if we avoid the recharging first 2 to 3 minutes of runoff, which may contain some dust and other organic matter. But other things you can recharge freely, and fresh water will go inside the pit. by removing crust formed over the filter bed. You are using a filter bed. You have to remove that crust at least once in a year. I have constructed this pit in my house way back in 1990s, and it is still working. There's not much maintenance actually. Keep drainage lines away from the recharge pit as far as possible, because we are hardly having 200 average meter square drainage line, at least few feet away. Because once the drainage is leaking, this will go and fill the pit. So, working principles of groundwater governance. I think I will avoid this because there's no time. The first principle is groundwater should not be managed in isolation. It should be used to cover variations in surface water quantity and the quality as well as the groundwater. Okay, like that. Second principle, groundwater quality and resource needs to be harmonized with the land management. Land management planning is very important, as recharge, discharge, and pollution of groundwater is linked to all this land management. That means you as a planners, you are planning so much, but before planning, please think the groundwater, surface water there. The third principle is governance of subsurface space. That is what we are talking about, recharge. The fourth principle is needs vertical integration between all these things. Okay, at national level to local level and to the personal level. And then fifth principle is should be linked to macro policies of the other sectors such as agriculture, energy, health, urban and industrial development. All these policies should converge. That's with the water and groundwater. Okay. Okay. Next one, please. Next one. Yeah, you see, this is the picture when I was in Italy. I have taken. You think that somebody might have arranged a tap there? No, that is groundwater. Groundwater is coming through a spring, and I am taking that spring water directly from the groundwater. There is no pumping. It is by natural pressure. So there, the groundwater levels are very much just less than 2 meters or 1 meter. You can see such a very highly potential water. Okay, next one. Next one, please. You can see petrol, inflammable, water, highly inflammable. So be careful. Next one. Thank you very much. I think I have finished my slides. Just to leave some space for you people. I think I know a lot of questions are there to answer. Many of you are eager to answer. I mean, ask the questions. I am happy to answer.
Sir, we have few questions in the chat box for the participants, sir.
Okay.
On behalf of the participants, we will ask you the questions, sir. Can we go ahead? Instead of using four water concept like the JNTU using it successfully, why the governments are spending lots of money on the water projects? What do you suggest on this, sir?
I have not followed properly. Can you repeat? Sorry for that.
Sorry, sir. 1 minute. Yeah. Instead of using four water concept like the JNTU using it successfully, why governments are spending lots of money on the water projects? What do you suggest on this, sir?
Okay, what I understood is four water concept that was pronounced by our former engineering chief Hanumantrao Garu. That is in general, that is in the rural India. Using the rainfall water, soil water, and then subsurface water, and of course the normal water like either reservoirs at all. Together, actually, we should follow that principle only wherever we go. Wherever we go. In JNTU, you are asking, JNTU is having, I think that is the project actually given by CGWB. In JNTU, what we did is, we have collected all the rooftop water and then injected into the ground by creating some boreholes. And then water levels are, naturally water levels have improved, definitely. But don't think, one thing, don't think that wherever you have recharged, then all that water you can utilize. No, by recharging, it will spread far off. Not just you alone can utilize. But if everybody recharges, in general, in that region, groundwater level will rise. So that is the concept. Spending money, yes, spending money as far as possible in all these water projects. We must spend money in such a way that unless it is highly necessary, we should not spend, because less money is available. in the rural sector as well as even in the urban sector also. So to construct an international airport, you construct some other flyover, you will get a big money. Whereas in the still water projects, they don't get much money. That is unfortunate affair. That's a policy decision anyway. But still, we are getting good projects. Earlier, we used to have only 2 reservoirs. Of course, only one reservoir, Hussain Sagar, that is not there now. Completely spoiled. Then Imai Sagar and Usman Sagar. Then we have went for Manjira. Like that, now we are getting from both the major rivers like Krishna and Godavari, we are getting water to this Hyderabad. What I appeal to every one of you is, when this water is coming from such a large distances, you see, how we are wasting? We are simply allowing that water. We don't never bother. Just I have given example. Our sumps are filled and water is simply flown to the road. The road is also spoiling. Not only you are wasting your water, such a costly water. In fact, all that cost you are not paying. That is a fact. They are not charging you all the cost. You just go and ask HMWS and SB. In fact, I have a lot of slides on that. But anyway, that is not the proper way. Okay, I don't know whether I have answered your question or not, but this is my feeling. Okay.
Hello.
Okay, next.
Hello.
Madan sir, can you please mute?
Hello. Are you able to live?
Continue, KP. Continue, KP.
Yeah. Yes, ma'am. Sir, the next question. How do you like the water management with climate change? What is the architect's role in water management?
How do you like the...
Sorry, sir. How do you link the water management with climate change? How do you link the water management with climate change? What is the architect's role in water management?
It is a very straightforward question. I tell you, first of all, due to climate change in future, we are going to have more floods and more droughts also. Then what we have to do? You have to make high when it's sun shines, right? When you get water, you have to store it and then distribute during the non-monsoon or lean period. That means, as far as the architect's point of view is concerned, design in such a way where our surface water is conserved. For example, rainfall water is coming. Even in the community, I was okay. Individual household bits all I discussed. Whereas in community recharge bits I have not discussed. Your own rainwater on the roads. You can design the pavements in such a way where this rainwater goes into the pavement and then get recharged there itself. Okay, you have to design the urban spaces such a way that they get recharged into the ground. The rainwater gets recharged into the ground. That is a simple, very straightforward technique. Such a design you must evolve. Porous pavements, for example. Porous pavements, at least open spaces. Porous pavement. You need pavement, no doubt, but it must be porous so that the water can get infiltrated easily. That is the architecture. I mean, you can. Another important thing is, even for the construction of the big buildings and then households and all, as I have already asked the question, how many of you are having these recharge bits? Almost less than 10%. I doubt. I don't know. You can conduct a poll now. Okay. So why we are such a, neglecting attitude? You can construct the house, even crores of rupees, including that villas, of course, nowadays the awareness has come, many of the villas have, but even the design also faulty. I have shown the design where it is faulty. They simply filling that entire thing to the brim of the pit. They should not fill. You should leave a gap. Okay. So while designing the pit also, you must feel that it should work well. Otherwise, there is a waste of money. HMWS and SB pit, I have shown an example there in the street. Okay. So the design in such a way, your planning should be such a way, the water must be conserved. In the household also, for example, there are so many, you can even in your order those fittings, through online, the more and more your droplet is made smaller foam like droplets, you can save much and much water. See, you are turning the tap, it is simply flowing. How much water, actually percentage of water you're utilizing? You're utilizing only less than 10%. Remaining 90% is flowing to the drain. But if the same water you convert into a mist like thing, you can save a lot of water. Such type of planning, such a manufacturing, such type of supply, such type of culture must come out, so that you must suggest to the government, you must suggest to the policy makers these ideas. Otherwise, they never think about this water. Suppose this year rains are very good, okay, everywhere borewells are working, nobody bothers. Next year there will not be any rains, all borewells are get dry again, they will, what you want to do? We don't have any planning at all. So this is where the planning is lacking. In the hydrological sense, hydrologically sensitive planning, hydrological sensitive planning must be there for architects. Okay, thank you.
Sir, next question. What about Mission Bhagirath, in which water carried from about many kilometers?
Yes, definitely. Mission Bhagirath and Mission Kakatiya, they have made wonders, I should say. See, once upon a time, when I was going to field work for this groundwater exploration, the farmers used to say, sir, we have not taken a bath even days together when water was scarce, particularly during summers. But with the availability of Mission Bhagirath, whereby through pipe we could able to supply each and every uh, household by some kind of connection. And definitely Mission Kakatiya also, we have desilted all the tanks and then allowed that water to percolate. Many places groundwater levels have increased with the Mission Kakatiya. Mission Bhagirath is essential because tapped water supply is very important, because pollution is the major problem both in surface water and groundwater. So once at central place, you will be treating the water. Just like in Hyderabad, they are getting water to the villages also. 80%, 80 diseases can be, you can get 80 diseases by not having proper drinking water. So you can avoid these diseases, okay, by having proper drinking water. Another important thing I want to tell you in this because many of you are drinking RO water nowadays, okay. Every office cans are filled, and that fellow will supply these cans, maybe 25 rupees or so. But unfortunately, that can water, if you test the TDS, total dissolved solids or salts, strictly speaking, you can test it, it is less than 100, not 100, even 50, 60. That much removal of salts is not necessary. You need for the body at least more than 150 TDS. You ask your RO plant person, at least show the TDS more than 140 or 150. Otherwise, your minerals, body require minerals. You are removing the minerals. Actually, we call it mineral water because after RO, you have to add minerals. In normal companied water bottle, they may add, of course, good companies. I don't know other companies. Okay. So, but these people who are putting these RO plants every corner of our street, almost, our colony, they're not adding all these minerals. They're removing it. But there is an arrangement, we can turn it in such a way that TDS is around 150. But unfortunately, they are not doing. This is a major setback. Even we are thinking that we are drinking RO water, very safe, nice. As far as bacterial removal and all, it's a safe, but minerals are lost. So this is the one campaign we must make. I have made a lot of this campaign. Now, even in the government, major government policies, they said TDS, they are now speaking about on the RO. Okay, next one.
The forests and hills are called as the water towers. Please throw some light on this to enlighten the architects.
Definitely, you are 100% right. See, unless we maintain a very at least 30% of our land in total, and on average. I cannot give you everywhere 30%, but on an average, 30% of the land should be covered under green cover. Why? Because your monsoon, because of these organic aerosols, see, fortunately, I have worked with cloud seeding operations of government of Andhra Pradesh, the then government of Andhra Pradesh. See, when I have seen my radar pictures, as and when this cloud passes through heavy density vegetation, then in the cloud, water content we measure through the radar, it is enormously increasing. Why? Because organic aerosols are acting as a cloud condensation nuclei. So I don't want to charge you with a lot of that physics, cloud physics, but it is always have very good vegetation nearby, either by small hillocks or by even a forest, so that you can maintain this ecological balance. But unfortunately, what is happening nowadays, much of the green cover is being removed. But policies are there. In fact, when you go to IIT Hyderabad construction site, last time I went there, they are telling they have to take permission to remove from central government environment forest. They have to remove these trees. Even in our present MCH also, there is a policy. Nowadays, trees are, whenever you are removing, you are just remove and then plant it somewhere. So policies are there, but still that is not good enough. The damage has already been done. See, these hillocks with green cover are really water towers, no doubt about this. They enhance the rainfall. We have to increase. That's why our government also asking to plant samples. These, already we have distributed Haritaharam and all programs. We are educating wherever possible. We put trees. They will attract some. It's not attraction. It's a total. You see, a tree gives you alone most of the oxygen. It can take carbon dioxide, carbon sequestration. First of all, much dangerous. This is another situation. No, now the 400 ppm we have crossed the carbon dioxide levels in the atmosphere. To sequester that carbon dioxide, these trees are helpful. This is very important. Okay, that's one side, water, this side. So a tree is a biggest, he is like God for us. Okay, thank you. Next one.
Sir, can you share some successful water management projects of India or abroad?
No, you are asking a very general question, but anyway, doesn't matter. For example, Israel, everybody talks about. We said there is hardly any 150 mm rainfall. Imagine, we are having 1100 mm rainfall. Still we complain. Is there any real... that means we are not at all using any scientific use of the water. First of all, let me explain. Suppose if you have a conventional irrigation system, for example, you have a drip irrigation system. Let us compare. You can produce or you can cover cultivation or you can provide irrigation to the land 4.5 times more than the conventional irrigation system. Of course, everything cannot be produced under drip irrigation, but most of the things, particularly your vegetables, fruits, many other things, cereals, even cereals also, in ICRISAT research, they said, yes, with the sprinkler irrigation, it is possible to grow the rice. So, particularly in the irrigation, you have to use water sparingly. For example, you are talking about Mission Kakatiya, Mission Bhagirath earlier. Now I am talking about Kaleshwaram project. See, what is the Kaleshwaram project? We are pumping Godavari water all the way 600 meters high. And you are leaving that water in the fields on a gravity flow. Is it not a crime? Is it not a crime? You have to distribute that water through sprinkler and drip irrigation systems. Because you are spending so much of money to bring that water. So, all micro irrigation systems must be encouraged at a macro scale. This is at a irrigation level, because most of the water is used by the irrigation. But unfortunately, what is happening? These are governed by the farmers community mostly. To invest in this micro irrigation, he needs money. Where he is getting money? Already the entire entrepreneurship of agriculture is under danger, threat. I know, my father used to do agriculture. Once upon a time, he used to not only invest or buy new acres. Now he is not getting his own money out of investment. Then how can he install these drip irrigation systems? And of course, government is providing some subsidy. The problem is the farmer is not getting the proper agricultural produce price. We as educationists and people who are educated go to the vegetables bazaar and simply go on bargaining. Suppose if he says 10 rupees, can you give it to 5 rupees? Less than half the price. You imagine you are purchasing tomatoes, kilo less than 10 rupees, for example. Kilo, 1 kilo to produce how much water? 2000 kilos, 2000 liters. You are buying one bottle of water for 20 rupees, whereas you are purchasing a kilo tomatoes for 10 rupees. Is it not? Is it fair? This is where we have struck. Unfortunately, our agricultural produce is kept very, very low value. Unless it is increased at least 10 times, they cannot invest on water infrastructure. It's a vicious circle. If you cannot invest on water infrastructure, you won't get water for your drinking, all other needs, because they are wasting a lot of water there in agriculture. So please think while buying. But you can also ask, sir, when you increase 10 times, then how poor people can buy these, because it's a survival. Yes, either through some other generation of revenue. That's why many times we are giving subsidies to these farmers, but still it is not good enough. For in the name of fertilizers, in the name of power, and other way they are pumping a lot of groundwater because of these subsidies. What we have to do is give subsidies, no doubt, but you have to make the farmers to utilize these micro water saving technologies. I mean, micro infrastructure. So this is a big cycle. You have to invest on water saving technologies much more. That is very, very important. How do you do it? This is all financial management. Okay. That is of course, at a macro level. At your household, already I have discussed. I need not repeat many things. What is the research indicates? 20 to 25% of our water that is supplied all the way from Godavari or Krishna River to your house is being wasted at your tap. Either through leakage or through some other means, wasting. This is the research says. So how much you are taking care of it? This is also very important. Not even the people, they never bother about the leaking tap. Every drop it counts. By the day it leaks more than 2 to 3 buckets of water, means 60 liters of water. So this is a very, very, you simply say, oh, it doesn't matter. Hardly 200 rupees, 300 rupees, your entire water bill. Then there are highly subsidized water bills. You don't bother. Unless you charge for 2,000, 3,000 rupees, you will not able to save that. So this is how human psychology. Is it not? Okay, I go on talking like this. I think already it's 1:30 now. Okay, anything, quick questions, 1 or 2? No problem.
Yeah, one last question, sir. If any water audit done by Metro Works, what is the transmission loss? Any detailed mapping of water assets carried out by Hyderabad Metro Works?
Yeah, sure. Yeah, already I told, not only in our Hyderabad Metro, this water supply, HMWS and SP, even in the London, the wastage is around 25 to 30%. 25 to 30%. They go on, conduct some surveys, identify the pipe leakages. But unfortunately, much of the water is lost at your user's end. This is the research says. That's what I have just now repeated. Research says much of the water is being lost at the user end. All the water comes to your house, entering your house. You are wasting it by not providing any good, floating system at your sump, number one. Then you are not repairing your taps, number two. And your usage efficiency is very less. You have to convert that water into micro droplets by installing proper equipment. You might have seen some hotels and all, foam like thing it will come, is it not? So such kind of installation you should use, then you can save a lot of water. In fact, Microsoft and many of these Google offices, they have done it already. They are doing, because they are getting a lot of water bills. Your tariff is much lower for individual household, whereas for commercial it is much higher. They are covering from the commercial, they are getting lakhs of rupees of bills. That's why they are saving. So if they also charge you like this, then you have to get much more than your electricity bill. So this is how one has to move. Okay. Anything?
Yes, sir. That's it for today, sir. Thank you so much, sir, for your unrelenting responses for all the questions.
Okay. Thank you.
We would like to thank Dr. B. Venkateshwar Rao, sir, for his kind words of wisdom and excellent session. The session gave us an insight of the way faced at the environmental level and had very illustrative, detailed, and analytical case studies. Thank you, sir, for sharing the ground reality and helping us look at water management for sustainable development. Once again, thank you, sir.
Okay. Thank you so much.
Sir, thank you very much for this is Raj Reddy, sir, Director NAC. Thanks for accepting our invitation in a short notice, and your lecture is very elaborative and very detailed, and our architects and architectural fraternity enjoyed it. And we are looking forward to work with you in the future, sir. Thank you for your support.
Dear participants, this announcement is for you. We have next session at 2:30 by Ravinder sir. So request all the participants to log in by 2:20.